Angle relationships in circles. This is the second part of 12.5. We're at 12.5b. And if you missed the first part, 12.5a, just click on the description. It's linked in there with the geometry playlist. In 12.5a, we discussed the three theorems that we're going to talk about again right now with angle relationships in circles. So if the vertex of the angle is on a circle, that was theorem 12.5.1, then the measure of the angle is half the measure of its intercepted arc. So the measure of angle 1, right here, it's on the circle, the vertex. See that? That means measure of angle 1 is going to be half of this 120-degree arc, so it's 60 degrees. And here we have a tangent and a secant. The measure of angle 2 is going to be half of this 200-degree arc, so it's going to be 100 degrees. If the vertex of the angle is inside a circle, that was theorem 12.5.2, then the measure of the angle is half the sum of the measures of its intercepted arcs. So here we have the vertex inside the circle. Here's angle 1. The measure of angle 1 is equal to half times this 44 degrees plus this 86 degrees. So it's half times 130, so it's 65 degrees. And if the vertex of the angle is outside the circle, that was theorem 12.5.3, then half the difference of the measures of the intercepted arcs would be the angle measure. So here we have angle 1. The measure of angle 1 is going to equal half this 202 minus the 78 degrees. So when it's outside of a circle, we're going to use subtraction here. When it's inside of a circle, we're going to use addition. So the measure of angle 2 here is going to be half this 125 degrees minus the 45 degrees. So the measure of angle 2 is 40 degrees. We can find the measure of an arc. We need to find the measure of arc AF. So here's A and here's F. So we're looking for this arc right here. We start by finding the measure of arc ADB. ADB. That's this big arc right here. And the measure of angle ABC, ABC is 110 degrees, isn't it? It's going to equal half the measure of arc ADB. That was from theorem 12.5.1. If a tangent and secant intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So 110 degrees is equal to half the measure of arc ADB. That means the measure of arc ADB is 220 degrees. So now we found that. So it gave us that this was 160, this was 48. We're going to find this measure right here, AD. I'm showing 60, but that's because we did this work. To find the measure of arc AD, we do ADB, that 220, which is going to equal the measure of arc AD plus the measure of DB, this 160. So we have 220 equals a measure of arc AD plus 160. We solve for the measure of arc AD and get that it is equal to 60 degrees. So now we have this arc measure, and this arc measure. We're trying to find this one. And all of these arcs together plus this one are going to make a 360-degree circle. So we can do the measure of arc AF is equal to the 360 degrees minus these added together. So we're going to add 60, 160, and 48. That's going to give us 268. When we subtract it from the 360-degree circle, we get 92 degrees. So arc AF must be 92 degrees. Now, for this one, we need to find the measure of arc BE. So it's going to go from B all the way here. So we're trying to find this lime green arc measure. And it's telling us that arc AB is 48 degrees and arc AF is 86 degrees. We can see we've got FGE angle right here is 79 degrees. Well, if we find the measure of FE, this one right here, we can add arc AB, the 48, plus AF, the 86, plus whatever that is, and it'll make a 360-degree circle. We can subtract their sum from the 360. So, using theorem 12.5.2, half times the measure of arc FE plus this arc measure, this 48 degrees, is going to equal this 79-degree interior angle right here. We can write the whole thing over 2 to get rid of that fraction. And 48 divided by 2 is 24. We've got the quotient of the measure of arc FE and 2 plus 24 equals 79. We can subtract 24 from each side and get that the quotient for the measure of arc FE and 2 is equal to 55 degrees. We can multiply both sides by 2, and we'll get that the measure of arc FE is equal to 110 degrees. So now we know that that's 110 degrees. Now, when we were looking for the measure of arc FE, we also could have just done half the measure of arc FE plus half 48 is 24 equals 79. Subtract 24 from each side, and then multiply both sides by 2 to get that the measure of arc FE is 110 degrees. Same answer, I just wrote it over 2 in the other way. Like this. So now all we have to do is total the 48, 86, and 110, find the sum, and subtract it from the 360 to find out what arc BE is. We subtract their sum from 360. The measure of arc BE is going to equal 360 minus the measure of arc AB, that 48, plus the measure of arc AF, that 86, and the measure of arc FE, which we've just found was 110. We find their sum, which is 244. We subtract it from 360, and we know that the measure of arc BE is 116 degrees. So sometimes when you're looking for the measure of an arc, you might need to find the measure of another arc and then subtract all of them from 360. So that's it for 12.5. Our next video lesson is going to be 12.6, which is split into 3 parts, A, B, and C. We're going to start with chord-chord product theorem, then we're going to do secant-secant product theorem, and then we're going to do secant-tangent product theorem. So just remember, if you missed the first part of this lesson, you can just click on the description and watch it, because I go into detail about the theorems that we discussed right here. I hope you're doing well, and I hope you were able to follow along and keep trying, and I'll see you next time. Bye.